Hello, hello, hello. It has been an entire year, which means there is another advent of code to tackle. And that is what I plan to be doing here today and for the next 24 days. I'll be tackling most, if not all, of these here live. Can't catch them. I'll re-upload these on my YouTube, which I've already been doing for the Everybody Codes, which if you haven't heard of, is a variant of Advent of Code made by a cool fan. But yeah, we're not here for that. We are here for Advent of Code. The way we're going to be tackling that is relatively straightforward. Gonna just try and solve this problem as fast as possible or as straightforward as possible. Then I'll come back, review it, review the problem, review my solution, all those fun different parts. And then that'll be it. I would have done it. That'll be it. So, with that, I do have a little repo. No fancy automated scripts, just a simple template here. I'm going to use Quokka to give me some real-time output. I believe. Yep, there is my repo. Advent of code. Link is below somewhere. Well, without further ado, let's go for this. Okay. An example, it's distance of 11. Example input is this. Interesting, distance of 11. Okay, get my puzzle input, get this file, put it in my input file, not sup world. That was left over. Okay, so now we have that. We need to solve the problem. To find out, pair up the numbers and measure how far pair up the smallest on the left, the smallest on the right, second smallest. Okay, so sort them both. Cost list equals data splits by the new line. Map line I list equals this empty one, this empty one. Here we go. We're not gonna do a map. Now we're gonna say list dot push line dot split by indiscriminate number of spaces. So // yep, split by that dot map part. Well, I list I dot push p as a number, and what I want to see is list look like that. Let's not import a thingy from a place. Boom. So 342133. That's 342133. Yeah, that is correct. My eyes are freaking out a little bit of this. I don't know what I'm looking at. List 0. 3421 342133. List 1. Yeah. The heck is that? Oh, I'm doing a push on a thing. Okay, great. Finally have my list. Just need to sort them, pair them, do stuff with them. Total distance between total left and total add the distance of all the parts. Okay, there we go. List dot for each L dot sort A B sending descending A minus B const distances equals list. No, stop importing the weird thing. Don't care about that. Need the index. Have the index. I can turn, what is it, the difference between them? The distance between them is 2, so that's math abs the distance. That is a list I 0 minus list 1 distances, right? 1 and 0. Dang it, I don't need to list over the map. I need to list over the things there. And this will be not I, it's 0 and 1 and then I. So I have goofed already. And nope, all my symbols going in the wrong places. That's not right. 0, 1. Okay, so 2, 1, 0. Sum them up. We're done. Turn distances this A, B plus B initialized to 0. We have a value. Let's drop the console. Cannot read. So I've done bad parsing. Let me first look at my input. Do I need to? Okay, so they're multi-digit. Let me watch out for a trim here. Nope, cannot read undefined regarding push. Let's look at each split. Maybe I've done this wrong. Y'all look good. Oh, look, there's extra junk at the end. That's exactly what we wanted. So this will need a trimming first. And look, it's a number. Is it the right number? About to find out. Boom. Okay. Part 2. Another input. Give input. Input is given. What am I supposed to do? Similarity score. Ooh la la. Okay. The first number in the left list is 3. It appears in the right list 3 times. So number times count of it. So I'm counting the things in the right list. Okay, I can still do the list parsing. Aside from that, though, we're not could be able to reuse a lot there. So now we just need to do counts and list 2. It's seeing single characters only. Similarities, add up all the things. Adding up each number on the left after multiplying the number of times the number appears on the right. Okay, that's good. So const in list 2. Don't know why I typed it all wrongly. Now we're just gonna do simple character counting for const. Well, they're not characters, but I guess I'm doing that. Of list 1 if car and in. That's a really weird name I gave it. I could have done this a lot easier, but I'm doing it this way. And list 2 plus equal 1. Great, we've done it. Not assignable to never. Shut up, TypeScript. Now scores is return. Well, scores equals list 0 dot map the. So it's it times the number of times it appears in the right list. Yeah, I believe so. So there's return C times in list car. Drop it to 0 in case it never appears. Now let me look at scores. Excuse me. Let me look at scores. Why? Something's went wrong here. Is it TypeScript or is it failure? Char is not defined. That would do it. It's the letter C. 940099. 940099. Okay, add it together. Boop. Come on, keys. Boop. Reduce sum. It's another big number. Put it in the box. Boom. We got it. Woo. And that was day 1, folks. Okay, let me get back in there and whew. I'm always curious to see what's going on. Where are the timings per day? Okay, so I look at it. Ooh, okay. 2 minutes. 2 minutes. Yeah, well, I'm gonna get there in a while. So that is it solved. So before we move on, we'll commit it as is. As you can see, I got a lot of old uncommitted stuff I gotta clean up at some point, but that's okay. To add Mish log. Oh hey, Celeste the best. Thanks for the sub. Much appreciated. Using up that prime. Hope your day is going well. I don't remember how I used to do any of this. Guess that's what I used to do. I appreciate it. Yeah, it has been a long time, but it was coming along and I figured, I'll give this thing a shot again. Thankfully, I kind of already warmed up in November with Everybody Codes, which is similar to Advent of Code, but just spawned it this year. But yeah, trying to get back in the hang of things. Did it not commit? Oh, it did. I just can't see it. No, it didn't commit. Oh, I had unsaved changes. Dang it. There we go. Okay. So we got that working. It has been so long. But what is usually the next part of the plan is walking through the challenge. I'll then go through how my code does it, factor how my code does it, go through how that new code does it and why it's so much better than the old code. And that will be it for the day. Looking generally at the problem. I could see some kind of fun visualization being made from this or something neat, but not enough interest in for me to take a stab at it tonight. So, probably should read some of this. There's some good story in here. The chief historian elves. Cool. Okay. So, these are two separate lists side by side, given to us in exactly this format with spaces in between them. Pair up the smallest on the left list with the smallest on the right list. Second smallest on the left, second smallest on the right. All of those, pair them all up together. Get the distance between the pairs. So, like the 1 would be subtracted from the 3, and the 2 from the 3, and then 3 from the 3, then 3 from the 4. It would be going through all that, and then you'd get them all summed together, and that'd be your distance. Let me actually walk through that one right now. Ignore that. That was some other problem. So let me change this back to monospace. And yeah, so we get the smallest and we pair them together. Let me get this going here. Got a little bit of space. And yeah, so this is how, like, if you were to manually do it, this is what you'd be doing. You'd grab with your eyeballs, you just look through it and be like, where's the smallest one? Here it is. Then you'd smash this one together with, where's the smallest one? We have 3 threes, so I'll pick that one. And then you do it again. So the next one, where's the smallest? This 2 to this 3. Then where's the smallest? This 3 to this 3. Whereas the smallest, this 3 to this 4. And then the smallest is this 3 to this 5. Smallest, this 4 to this 9. If I've done that right, I want to look at my input. Okay, so they don't really say it. 1, 3, 2, 3, 3, 3. What if I've written these out? But I didn't. 1, 3, 2, 3, 3, 3, 4. What have I done? No, I've went through the process and then I just drew a bunch of lines. So that really made it easy to follow, didn't it? So 1, 2, 3, 3, 4. And then 3, 5. And then 4, 9. Should I go back to their list? Yes, that was what happened. So if you continue to do the math, it's the difference between them is 2. Well, technically it's -2, but if you absolute it, the difference is 2. Difference is 1. Difference is 0. Difference is 1. Difference is 2. Difference is 5, 4, 5. I know how to do math. Then you add all these together. So let me just go down. 2 plus 1 plus 0 plus 1 plus 2 plus 5. That will equal 3, 4, 6, 11. Ta-da! So that's what you're supposed to do for the first one. For the second one, right, it's the counting one. So you're supposed to go through this list, and for each of the ones in the left list, multiply it by the times that number appears in the right list. So if I were to bring that over, we go through that one, go a bit more real estate. So we start with 3, and we see how many 3s are there. There are 3. So, how do I want to represent this? I don't want to represent this. Okay, so it's going to be ugly, but we're just going to do this. Look, there were 3 3s. Alright, so it's 3 times 3. Explaining it's easy. Visualizing it, not so much. 3 equals 9. There we go. Okay, this is the plan. Do not worry, I have the plan now. So we have our 3 3s. We did the math. Then we're going to go on to the next one. So we're going to do this horizontally. And now we're going to look at the 4s. How many 4s are there? Not F5 to refresh. I want my normal arrow. I guess these arrows are relevant. Boop. There we go. They're a bit big. Let's smush. Oh, jeez. There we go. Alright, you're just getting distracted here. So there's 1 4. Oh, okay, so it's 4 times 1. 1 is 4. Okay, next frame. How many 2s do we got? 0 2s. We just 2 times 0 is 0. How many 1s do we got? 0. 1 times 0 is 0. How many 3s do we got? We already had that answer questioned. That question answered. We have a 1 3, a 2 3, and a 3 3. 3 times 3, we already know this answer, equals 9. 9. And then we're going to do it for the next 3. Very exciting. 1 3, a 2 3, 3 3. 3 times 3 equals 9. which gives us 9 plus 4 plus 0 plus 0 plus 9 plus 9. Is that correct? 9400099. 31. I'm going to trust 31 is how you add that together. And that is the manual process of doing the second one. Now, in me just doing that, I can already see an optimization I didn't take that I planned to do in my refactor. But before we do that, we'll walk through what my code actually does. Because this is the manual way, and this is completely functional. But what my code does is it does it a little bit more efficient way. So it takes these lists, or this string rather, and it turns it into these two lists, which I could, put them more in that TL draw, but it's a little easier to see them. So, list. So it builds these two arrays of all of the individual numbers in the list. But how does it do that? Well, it goes through every line, which as we can see, when we visualize it, it looks just like that. And it splits them by the space here. So if I were to show what that looks like, excuse me, there we go. And we use a little bit of regex here because, as we can see in the hover, there are 3 spaces there. Now I can split by 3 spaces, and if I'm lucky, aka that's also 3 spaces here, okay, that is something I could have done, but instead I use regex to say, hey, just capture as many white space characters as you want and split by that. Be cool. Once you do that, I want you to map over them, give me each character and every index of the character. And then I say, okay, take that character and put it into that list. Now that part's a little magic there. I'll change this to a for each, it's more realistic. But I'll show how that works. So P, well, let me just console log it. There we go. So remember, we have 3, 4, 4, 3, 2, 5. So we get 3, 4, 4, 3, 2, 5. So as you can see, each one that comes in, it's reading from top left to bottom right almost. So 3 and then the 4. So it's that first line, and then we get the index of that element in the array. Because remember, this gets turned into a nice array of strings. So this is the 0th one, this is the first one, 0, 1. Or left, right, left, right, left, right. And then we use that index to figure out, well, which list do I want to put you in? Do I want to put you in the left list, which is represented in the 0th index, or the right list, which is represented in the 1th index? Based on whichever one you want to do, you push it in there. Then we'll use the old unary plus operator to turn this string into an actual number. That gives us these 2 awesome lists here. Now, I didn't do the old manual arrowing and finding the smallest. Because as you saw when I did that, I had to first find the smallest in here. So I had to search with my eyes through all of them. So N, in this case N is 6. Then I had to search with my eyes through all of these, which was also 6. So it's 6 times 6. It's very bad, big O efficiency. So instead of that, I just say, hey, you two should sort yourselves, and you should sort yourselves ascending. I'm not going to get into the fancy math behind this, but the trick is if you're sorting numbers, you can do A minus B and just be like, oh, A will be first, so the lowest value will be first. Or you could put it the other way, B minus A, the largest value will be first. Or you can keep it however you want, do reverse. Again, I'm not explaining how the dot sort method works in JavaScript. The MDN is there, unless you all want to hear about it. So then we sort them in the list. Look like this. Stop importing the dumb thing. Looks like this. So 1, 2, 3, 3, 3, 4, 3, 3, 3, 4, 5, 9. And this is where it gets a lot easier than what I manually did there. So I'm going to duplicate this. I already duplicated it. I'm going to make the list in that way. So actually I can use this. Console log. These two things. I'm just using this to help me generate what I'm going to say. Okay, I like it. 2, 3, 4, 5, 6. Show me the space, or don't show me. Okay, there it is. Beautiful. Give. Okay, now I can put this here, and look at that. So these are our things, and as we can see now that we've sorted them ascendingly or descendingly, it didn't actually matter the order. The smallest pairs are directly across from each other. I'm not going to draw all those arrows, which means as we loop through this one, for example, with an eye of, well, with an eye of right here, we just be like, hey, so we're at this index, which is 0. I'm looking at this one. If I use that same index in the other one, I'll have this one's smallest pair. And then we do that for the next one, and we do it for all of them. And then we take that, we do the differencing logic that I already showed here, get all our numbers, and we add them all together. And this is the code for that. So we pick a list, they're both equal size, so it doesn't matter. We go through them. We don't care about the value, just for consistency in the code. We only care about the index. For each of them, we subtract the left list value from the right list of value. We do the absolute because we don't care about which way it is. We just care about the difference, the absolute difference. And then that gets us the distances, which are right here. After that, we just want to add them all together. The reduce, for those who aren't aware, allows you to easily sum up an array of summable things. This little shorthand here. And yeah, that is how my code works for part 1. Oh, hey Rask, let me know when you're back. Yeah, it's nice for me to be back too. So, solve 1, gonna put it back. Did I break it? No, TypeScript is just angry. This is how math works. Yeah, it feels like it's been a minute. Yeah, Rask, it's glad to be back. It's been a long time. Yes, it has. Advent of Code has started. I almost missed it because I'm in a different time zone than I was last year. So I was like, oh, it's going to be great at midnight. It's like, nope, it's 11 o'clock over here. But yeah, Tata the 5, Advent of Code has started. Day 1 went pretty well. Yeah, that was my walkthrough of my code for part 1. What did I do for part 2? Nobody knows. Go for it, yeah. Yeah, I mean, no, I didn't change job. I just moved to my job. It's the same one I had before with Source Allies. It just was in a different state, so I was doing a remote, and I was like, might as well do a little hybrid. Now I'm with the corn. Yeah, so this here is the manual way. You saw how gross it was. So the code white does all the same stuff. But then we get efficient. And there's even a more efficient way that I recognize that I didn't go for, but I didn't get to it. Basically, we create a map, hash map, and we just count how many times the characters have appeared in here. So instead of being like how many threes there are, 1, 2, 3, we just go to the count and like, hey, how many threes there are? There were 3. I already looked at it. And we do that for all of this. Yeah, Rask, I am enjoying it. No, it's consulting. It's not too different from freelancing. It's all the fun parts of freelancing, minus the not fun parts of, hey, you do your own taxes, you do your own marketing, you do your own sales, you do your own everything else. It's like, well, no, I just wanted the fun parts of freelancing, and then the consultancy existed. So yeah, I am enjoying it greatly. I think. Yeah, so with this list, take the list. What did I do with the list? I don't know. I take the list and I take this side of it, and I'm like, hey, I'm gonna make a count of you. And that's what I'm doing in list 2 is what I called this. Equals a hash map. Yeah, it's not exactly QA automation. I'm still making sure things are functional and well tested. I moved on to a different, same job, different client slash partner. But yeah, I'm doing some, cool think. Yeah, still doing some cool things around testing, making sure non-deterministic applications can be relied on. It's fun. What have you been up to, Rask? SRE, kinda. The heck's an SRE? Oh, okay. Not exactly. Still on the side of making sure it's making sure the new software works. So it's, think LLMs, that kind of non-deterministic nature. So testing. It's still testing, but just making sure testing different kinds of software. Being like, hey, how do you test this thing that like you ask it one thing and it gives you 5 different answers? It's like, got you. Nice. Maintainers of an internal design system. Interesting. Yeah, hey, keeping the wheels on the bus go round and round. Very unappreciated. Nice. Yeah, yeah. Let me think. With this list, yeah, so the way I did build the hash map, the count map is basically how many fours do we got? We got 0 4s. Where'd all my numbers go? How many threes do we got? We got 3 3s. Fives. Well, we don't have 0 4s. We have 1 4. I am a fool there. Then we have 1 5. Yes, they will. It's all good. It's all for the fun of it, right? Then we look to count threes, and they're already counted. Look to count nines. There's only one. So this gets turned into this. If I look at it, that's the real one. Don't want to eat my computer alive. Boom, 3 3 4 1 5 1 9 1. So that's what that turns it into. we do this trick to say, hey, if we haven't seen you before, then we've seen you 0 times. We do this because if you plus equal an undefined, JavaScript will die and will give you not a number. So do this, it's 0, do this, add 1 to whatever it is. Then we do that multiplication of the number in the left list times the number of times in the right list, but it might not have ever been in the right list, right? So we say, hey, if you're undefined or null, which is what this little optional chaining operator does, I forgot, you're a 0. So it'll be timesing 0 if it's never been seen before, because something that's never been before has been seen 0 times. And then finally, we do the same old reduce trick to add all the numbers in the array together. Now, that works, but I already noticed something as I was going through this, and I will go through that probably after the break when my refactor. We calculated how, like, this score for 3 times. Absolutely gross, absolutely inefficient. We will never launch rockets to the moon with this inefficiency. So we're going to eliminate that in our refactor. Hey, Rask, yeah, of course. Thanks for coming on by. Yeah, let's, don't want to ruin anyone's sleep schedule over this, so it's great seeing you again. That, it's good timing on all the things, because that's the walkthrough of part 1, part 2, my initial code to part 1, my initial code to part 2. All that remains is a refactor, but I'll be doing that after this break. So I'll see y'all on the other side. We are back at it again. So, plan is to take this amazingly perfect code and make it even better. A little bit of refactoring. So, first thing, generally easiest thing to do is testing. We have tests that make sure that our code works. I'm going to go ahead and turn these console logs into asserts based on these numbers so we can have more tests. Give number. Now that we know what's expected of these two, we can have all the tests in the world. The reason we like tests is they help us make sure our code does the thing we said we wanted it to do. And the reason we love tests right now is because they make refactoring a breeze. Now, yes, I'm not officially using any testing framework, just out here using asserts, but they're still tests. So, now that we have all of our stuff here, we can break as much as we want and we'll know if it works. Everything's green again. So, first thing that's easily refactorable here is the duplication of the list parsing. Literally the exact same 4 lines. And then we have generation of scores, similarity score, total distance. Okay, so they're not generating the same things. Because the next point of duplication, it's really just a one-liner though, so it might not be worth the effort, is just this reduce of whatever numbers you do generate. So I think I'll just go for the parsing, deduplicate that, and then we'll go for the next easiest thing. Parse list, data string. We're going to return from here a number list and a number list. This is a way in TypeScript to say tuple. Oh, not remove, whatever that was. Return, nope, not that. Return list. Why are you not happy? Never, number. Oh, okay, so this is just dealing with the types of TypeScript. Very fun. Yeah, we'll say that's what this is. That also resolves this, because now we know what they're being pushed to. We can return it. Now we'll know if this code works if I can replace my old code with the new code. Still works. Still works. Okay. Next bit is clean this up a little more. We don't need that trim. Do we need this trim? Apparently we do. Why do we need this trim? Did you put extra spaces after stuff over here? Who's responsible? No, not there. Did I put extra spaces in? I didn't put in extra spaces. Okay. There are extra spaces somewhere. I might blame Windows for it, because it does things a little differently with characters that I'm familiar with. So we're blaming Windows for the extra spaces. But what we want to do is for each of these lines, so I'm abusing map in this instance, but I like to not abuse map. I do prefer traditional. So for every line, we're going to do this stuff. What stuff? This stuff. Yeah, so for every line, we trim the line, we split on the characters, and then we do another combination of stuff. So this is a loop within a loop. How would I like to make this? This is technically functional. Gives us the item, gives us the index. Kind of mixing styles here. So for consistency, let's do it again. Const I, and then what is this? Digits of the list trim split entries. Go. Now we can drop for each and just have the pushing. Of course, not a P because I've moved away from single digit variables, doing all the good stuff there. Now pushing just like this. In my opinion, easier to read, easier to follow. And clearly, much more obvious that we're doing 2 for loops in here. Yes, we could do some fancy maps. No, I don't want to do any fancy maps just yet. Don't want to scare you all away with unreadable code golf. So we have this working. We are parsing our list, and then let's dive into the part 1. See where this can be done better. So for each of them, we're sorting them. That's functional. For distances, we do not need this return statement as it is a single expression arrow list. And are they distances? Total distance. Okay, and then we generate total distance and return that. Yep, that's good. If I really wanted to be golfy, I'd do that, but that hurts readability, so I'm not gonna do that. There we go. I believe there's clearly one operation going on. We get the list. For each list, we sort it. I'm gonna go the loop again. What can I say? I like me a for loop. For every list of lists, we sort them ascendingly. In this one, we are abusing the map, kind of, but not really, because we just need to map that many times. The alternative, which I don't think I'm really going to go for, is doing this for let 0 I less than. It's basically this. So, functionally equivalent. I like the way it looks better. What can I say? Yes, it's not pure, but I like it. Now, the only thing that I don't like is that we lose a little bit of typing, but boom, I just solved it. So we sort our list, we get the distances between them, we add up our distances. Let's make types a little happy here. Number. Oop, there we go. So let's 2 counts. That's where we can start with, because this list or this hash map is just a count of how many things we've seen in list 2. Then we have scores, which again can single line this expression, and then we just add up all the scores. Now, thanks to me walking through the process, I was able to identify some clear rework here. So if we already have calculated the score for one of these numbers, we don't need to do it again. How would I like to do that? The naive approach in me is telling me to just create another hash map of, what do we call this? Calculated scores? Yeah, let's go that way, and then we'll think of a better way later. Let's calculated scores is this. And then what we do here is, instead of doing math and lookups, we say, hey, if C in calculated scores, return calculated scores C, else score is that. Calculated scores C equals score, return score. Now we're not going to see it on such low inputs, honestly, but if we were to shut TypeScript up with a good type, and then look at when this happens, we'll see right here that the second and third threes have already been calculated. So they could go straight to calculated scores and be like, we're already here. We did it. Let's use what we figured out last time. This is not a large efficiency gain. If anything, it's probably minimal. So we're just saving ourselves from doing math. We're not even saving ourselves from doing a lookup because we're doing another lookup to get this value, technically two. And if anything, we're costing ourselves more in memory to save a couple cycle times. So I'm not even going to do this, but if I really wanted to, I could have. If this was an actual thing, you would take both solutions and benchmark them. But this is day one. Not going to scare anyone off by pulling out the benchmarks. A fancy thing I could have done here, because for those who don't know, this append operator, what this does under the hood is it says this equals this plus this. So that's what we just did under the hood. So what we can do is get us a few less operations and checks by just saying, as we can already see, it's exploding because it's an undefined here. But if we optionally change that to a 0 and be like undefined or 0 plus 1, we eliminate that if check. We eliminate this one-time operation per number, and we just do this here. It's more obvious what's going on. To those who know it and recognize it, yes. To those who don't, I guess it's a little bit more to learn, but it's cleaner. And yeah, that is everything done. Let's see if I want to go further here. I can do some destructuring. I don't want to do destructuring. I'll do destructuring here. Since I do actually have relations and we don't just reference them arbitrarily. So we have character of second, which now that I'm looking at it, it's not character, it's num. There we go. So now we can be like, hey, first list, second list. We could destructure it in this one. Then we'd have to call sort on both of them. But, let's go for that. Boop, boop. Oh, no. This. Now it's first sort. Second sort. And then we could just go through first length. Oh, hey, Artemis. How's it going? Thank you for the raid. What were y'all finding yourselves up to? Apologies, I don't have any of the fancy alerts or stuff going on. Haven't streamed in literally years. Oh, that doesn't work anymore, does it? Oh, it's this thing. As you can see by my failure to do that, it's been a while. There we go, figured it out. But yeah, hope y'all are having fun. Just doing some admin of code refactoring over here. Howdy, howdy. Mm-hmm. Yeah, so just brief recap. I solved part 1 and part 2 of Advent of Code. I walked through my the raw challenge of it, whiteboard style. Broke down how my initial code went through it, whiteboard style. And now I am refactoring it to be a little cleaner, a little more readable before I give it one more walkthrough and then call it a night and prepare for tomorrow. And that was actually the last refactor I was looking for. So, oh, apparently it's ads going now. That sucks. Can I turn them off? That's hard to tell. To answer the question, I'm using TL Draw. TL Draw. For those who haven't used it, it's kind of like a Scala Draw. It's the one you see on YouTube, all the cool people using it, but it's different. I think it's a little bit more open source. It's got, the collaboration thing with it too, so multiple people can work on a single thing. You can put screenshots in here, you can, mess about. You have a few shapes. You got some built-in sticky notes, which are nice to use, retro boards and stuff. Um, Basic text, some okay arrows. You just get this curve, but it's pretty good at snapping to each other. Apparently, like if you really want to, you can make some cool stuff since it is open source and basically React library usable. But I've yet to have the desire slash free time to break anything custom out with it. But it works. Yeah, so we have that, and we just finished the refactor. So we're gonna just go quickly through it and see what the great impact was before we go to finish it off. Yeah, Artemis, I like it. I think there was something that made me search for something better than a Scala draw. Maybe it didn't export or something, because this one you can export. Yeah, you can export to like a flat file, like a JSON file, and then import from that, which is nice. Uh, yeah, it's also very supportive of like embedding website iframes. I don't use this particular bit a lot, but you could put a TL draw inside your TL draw, so you can get real meta with it. Yeah, that's the main parts I use of it. It's kind of like Draw.io, but a little bit more whiteboardy, freeformy, and it does have a VS Code extension if you're hate leaving your editor. Right, so refactored code. It looks pretty good to me. I'm gonna commit it. Well, I'm a stage at least. So let's go on through it. Okay, Quack is still running. So they all go through the great list parser. It parses all of our lists. Goes through each line. Oh, let me turn off the real ones because that's going to eat my computer. There we go. So it goes through the lines, which is just taking the string and splitting it by new lines. For each line, it turns it into the 2 digits, and we also grab the index. So use .entries to get us a Python enumerate equivalent. So as we can see, we get 0, 1, 0, 1, 0, 1, which is left, right, left, right, left, right, followed by the digits in that column. So we take that left, right, we use that to determine which list we put it into, and then we push the digits, convert it to a number with the unary plus operator. Then we return the list. In part 1 land, we then destructure that into these two variables. We sort both of them in ascending order, which you can do So numbers like this. We make an array to store our distances. We go through both of them. Since they are both the same length, we can use just first length. And then we add the absolute difference between the two numbers to our distances array. Finally, we take our distances array and we add all of them together. As I am going through this, we do not need the distances individually. We can just straight up go total distance equals 0. Learn to spell the word distance. Add this straight to this. And return total distance. So not only does that do less, because it does less, that also gives us a memory increase. Because before we were going, well, O of n2 for the length of how much we're taking up in our arrays here. So if we had, let's say, 6 long, then our space was 12. But then we also doubled it. Well, we didn't double it. We added a third to it by going from 12 to 16 to store each one of these scores. Sorry, each one of these distances. But we just cut that in half. So we dropped our space by literally a third. If we wanted to be real nerdy, we probably could do something to go less, but nope, it's good enough. So that's how our refactored part 1 does, and you can already see probably what I'm going to do to the second one. Do the same bit right here where we go through each, we add up all the scores. Before we do that, first thing we do the parsing again. We grab the counts of 2's and we say, hey, how many times have I seen this number? Well, I've seen it one more time than I've previously seen it. Oh, I haven't previously seen it? Well, that means I've seen it 0 times. We finally have that map. We go through each of them. We multiply the number by, let's go num, by the number of times that number has been seen. Oh, this number hasn't been seen? Well, it means it's been seen 0 times. Then we add up all those scores. But same optimization we just found before. Let's add this all up. Similarity score. Okay, so this is just the similarity score, not total similarity score. Here we go. I'm gonna copy this because I totally know how to spell similarity right on the first try. Now let's demapify this and return similarity score. So for constant num of first. I hope I'm not doing a different puzzle than you. Path of a 5. I'm just Advent of Code 2024 day 1. This is the one that released. Yeah. Maybe you're doing a 2023. I know you can go back to the previous years. Somewhere around here. I know there's a link somewhere to go to the previous years. Oh, a different solution. Yeah, yeah. I mean, that's not uncommon. That's kind of the fun part of it, right? Like, it's the same problem, but there are wildly different ways to solve it. You get 2 stars by solving each part. So, like, the game part of it is you get a star for every part you solve, and when you have all of them, that adds up to 50 stars. So the stars will appear when you solve them. But yeah, it's kind of one of the funnest things about Advent of Code is that you get to see other solutions. If you only got one, that means maybe you didn't solve part 2. Or if you have, maybe your browser cache is being annoying. Do a refresh or a hard refresh. Someone has stolen your star. I'm kidding, that can't happen. Nice. Yep. Just had to be patient, I guess. Oh yeah, there are always parts twos. Go for it, buddy. I wish you luck. That's probably why it looks different. You're looking at my part two solution. Part one probably looks more close to what yours actually was. Yeah, last bit, we go through each number. We already did that. I'm reducing the space by just not building an array and reducing it, just adding one to another. That makes sense. Okay, with this, I was able to squeeze out a little bit more from this, both in readability and clarity. Yeah, with that, I can try to remember how I do these. Optimize 2024 day 01 TypeScript solution. I don't think I have my GitHub account on this operating system, so I'll push it later. But that is everything. That I plan to do. So let me go find another advent of code person, or if there's recommendations, and we will raid y'all on over to there. Well, we got some. Oh, there's advent code. Oh, there's a tag now. That's cool. One moment. I haven't done this. Hey, where'd the screen go? That looked weird. Preview said the screen went away. It's back. Okay, let's. I don't know this individual, but they're doing some stuff on Fortran, so let's go say hey to Jeff. Let me, one moment, check if they're not ending, because it wouldn't be the first time I've been like, let's raid it, and they just end. The screen keeps dying. Yep, we're gonna go raid this Jeff fella. They're doing advent of code in Fortran apparently. Their tags can be believed. But yeah, I won't be able to hang around too much. It is midnight. But hope y'all had pleasure. Bye.